Hello, this is the 6th video of chapter 9. So far, whatever hypothesis testing that we covered, they were all known as sigma known hypothesis testing. They were all known as sigma known. Now we deal with sigma unknown. And you guys remember back in chapter 8 when we were using sigma known, x bar plus or minus z sub alpha over 2 sigma over square root of n. This is for sigma. This is back in chapter 8. And then for sigma unknown case, we use t sub alpha over 2 s instead of square root of n. Similar to this situation in chapter 9, in chapter 9 we have sigma unknown case, which for sigma unknown case, instead of using z, we use t equal x bar minus mu sub 0 divided by s over square root of n. Okay? S being the standard deviation of the sample, because we don't have the sigma unknown. We use S and then we use T. Now this is what we do. We calculate our T. We find the T of the given alpha. If the rejection rule would be reject H0 if T calc is greater than or equal to T of the given alpha. For negative values, T calc less than or equal to negative T of the alpha. For p value, everything is going to stay the same, less than or equal to alpha. And for half of the alpha, the same. So the rejection rule stays the same, except instead of z, we are using t. Now, what is the p-value and the alpha? In sigma unknown case, this is what the p-value and the alpha is. You see these areas in boldface and top, those areas in boldface and top. Okay? That's where our p-value is, where we find our p-value, and also where we find our alpha. Okay, and those are the area and the upper tail. And again, when we are going to find the t value, we're going to do n minus 1 when we're going to find the t value to solve the problem. Okay? Now, there is an example here that I would like to go over with you. And on slide number 41, they have listed the rejection rule that I have listed it for you already on slide number 41. And then they are talking about p-value and t-distribution on slide number 42. Now let's go over this example on slide number 43. One tail test about a population mean sigma unknown. A state highway patrol periodically samples vehicle speed at various locations on a particular roadway the sample of vehicle speed is used to test the hypotheses. They say their hypothesis says that this is their null hypothesis, which they state that the mu is less than or equal to 65 miles. I think this is wishful thinking. Who drives 65 miles or less nowadays on the freeways? By experience, you can tell right now that you can go and reject this H0. But anyway, let's move on. The location where H0 is rejected are deemed the best location for a radar trap. Now, if this is the null hypothesis, the alternative hypothesis states that the mu is greater than 65. Okay? Slide number 44. Location F, a sample of 64 vehicles. So N is equal to 64. Mean speed of 66. So X bar is equal to 66.2 miles per hour. Standard deviation of 4.2. So S is equal to 4.2. With the alpha equal to 0.05. Okay? Now we want to go ahead and solve for this. The first step is formulate the hypothesis. The hypothesis has already been formulated. This is step number 1. Step number 2 is specify the level of significance. Step number 1, step number 2. Step number 3 is calculate your test statistic. T is equal to X bar minus mu sub 0 divided by S over square root of N. X bar is 66.2 minus mu sub 0 is 65 divided by 4.2 over square root of 64. So T, let me see what T value comes out to be. So T comes out to be 2.286. So 2.286. Okay? Now, if we want to go ahead and use p-value, okay, we have to go ahead and see where this is located at on the table. For 65 minus 1, that is going to be 64. Okay? Wait a minute. N64. Sorry. N64. N minus 1 for 63. So we go to T distribution table. Across from 63, degree of freedom 63, we go across, we try to locate 2.286. We don't find 2.286. Two closest value that we find are 1.998. Let me write down in here for you. So this is part of the table. So degree of freedom, we have 63. We have 1.998. Next to it we have 2.387. Now, if you go on top, those boldface values, 1.998 you will see this is 0.025, this is 0.01. These are the p-values, okay? Now look, for 64 minus 1, 63, we go there, we want to find our t, the t that we calculated, we want to locate it to see what the p-value is. Our t is less than this, it is more than this. In a case like this, it's somewhere in between. We do not know exactly what the p-value would be, but we would say it is between 0.01 and 0.025. So our p-value is in between 0.01 and 0.025. We're not exactly sure how much it is or what it is, but look, the alpha is 0.05. Even if our p-value is 0.025, which is the highest value, still less than 0.05, therefore we have to reject the H0. This is using the p-value approach. If we use the critical value approach, so for the p-value, we say that p-value is between 0.01 and 0.025, therefore reject H0. Why? Because 0.01, 0.025 is less than alpha. Okay? Now, for critical value approach, the t-calc, if it is greater than or equal to t of the given alpha, we reject. The t that we calculated is 2.286. Let's see what t of the alpha is. T of the alpha, we have to go and locate column 0.05 across from 63. Across from 63, column 0.05. Z of the given alpha is 1.669. Across from 63, 1.669. So this is 1.669. Therefore, this is greater than this. We go ahead and reject the H0. So if we go to the next slide on the example, on slide number 46, the p-value approach, yeah, it says right there p-value is in between 0.01 and 0.025. And then for the critical value approach, the t of the given alpha is 1.669 comparing to the one that we calculated, 2.286, so we have to reject the H0. Now let's do problems 22 and 23. Let's see what page or pages these are on. Problem number 23 and 33. 23. Let me see if 33 is the same for all editions. Yeah. So problem number 23 and 33. 11th edition users, page 375 and 376. For 12th edition users, it starts on page 409. For 13th edition users, it starts on page 413 and 414. It goes to 414. So problem number 23, consider the following hypothesis test. So chapter 9, problem 23, this is 12 and this is 12. A sample of 25, n is equal to 25. A sample mean of 14, so x bar is equal to 14. And a sample standard deviation, S is equal to 4.32. Compute the value of test statistic. Part A, T is equal to x bar minus mu sub 0 divided by S over square root of n. X bar is 14 minus 12 divided by 4.32 over square root of 25. So that comes out to be 2.31. That's the T that we have calculated. Part B, use the T distribution table to compute a range for the p-value. So we have n equal to 25. We go to degree of freedom equal to 24. Across from 24, we have to go ahead and see if we can locate 2.31. So I'm going to go ahead and (24) and 2.31. So we don't see 2.31 again. Under 0.025, so under 0.025, this is, let's say, 0.025, and this is 0.01. Okay, under this, we have 2.064, 2.064, and under 0.01, we have 2.492, 2.492. So our T is in between these two. Similar to that example that we just solved, we say that we're not sure exactly what the p-value is, but it is between 0.01 and 0.025. So p-value between 0.01 and 0.025. This is for part B. Now for part C, at alpha equal to 0.05, what is your conclusion? For part C, alpha equal to 0.05, because 0.05 is greater than this, or these are less than 0.05, therefore reject 80. Part D, what is the rejection rule using the critical value, and what is your conclusion? What is your conclusion? So using the critical value, the rejection rule is this: reject 80 if T calc is greater than or equal to T of the alpha. So T calc in this case is 2.31. T of the alpha, well, let's find the T of the alpha. T of the alpha, which is 0.05 for degree of freedom 24, 0.05 with degree of freedom of 24 under 0.05. The T of the alpha is 1.711. So this is 1.711. Therefore, T calc is greater than T of the alpha. We go ahead and reject the H0. Now problem number 33. Annual per capita consumption of milk is 21.6 gallons. So I'll leave it up to you guys to read the problem. Standard deviation is 4.8. So first we have to go ahead and formulate the hypotheses in here. Develop a hypothesis test that can be used to determine whether the mean annual consumption in Webster City is higher than the national mean. They believe that milk consumption is higher. So H0 states that the mu is less than or equal to 21.6. Mu is greater than 21.6. Now, why do we come up with this assumption? Is they say that the milk is 21.6 is higher. They say that you believe that the milk consumption is higher when they say it's higher in the other part of the country, then we assume that this in that city is less. That's the rationale for that. So a sample of 16, n is equal to 16, from the city sample mean annual consumption 24, x bar is equal to 24.1 and s is equal to 4.8. 4.8. Okay, now part A, develop that part B. What is the point estimate of the difference between mean annual consumption in Webster City and the national mean? In here, they just want us to find the difference. So this is for part A. For part B, the difference between this one and this one. So that's going to be 24.1 minus 21.24. Yeah, that's going to be 2.5 gallons. For part C, at alpha equal to 2.05, test for significant difference. What is your conclusion? All right. So T is equal to x bar minus mu sub 0 divided by s over square root of n. X bar is 24.1 minus 21.6 divided by 4.8 over square root of 16. So T that we calculated is 2.08. Now what we can do is we can just go ahead and use the p-value approach, or we can use the critical value approach. If we use critical value approach, we are going to have the T of the alpha equal to point, they say to use, yeah, they say use alpha equal to 0.05. So alpha equal to 0.05. For N16 we go to 15, and then alpha equal to 0.05. The T of the alpha is 1.7 1.753. 1.753. So T calc is 2.08 and T of the alpha 1.753. Our T is greater than that, we reject H0. Now doing the p-value approach. The p-value approach for 16, we go to 15, we try to locate 2.08. We don't see 2.08. It is in between 1.746 and 2.120. It's in between, so p-value is between 0.05 and 0.025, even if it is 0.05. So the p-value is between these two. Even if it is 0.05, still equal to alpha, and then we reject the H0. Bye-bye.